The world around us is getting smarter. It is becoming increasingly common to encounter words such as machine learning, artificial intelligence, and deep learning in newspapers and social media. But what do these terms really mean? Let's try to understand these terms starting with artificial intelligence or AI. Simply put, artificial intelligence is intelligence shown by machines. Now, there isn't a formal definition of AI which is agreed by everyone, and scientists often argue over what really constitutes intelligence. So let's start understanding AI with some simple examples, which most researchers agree with. The first one is a rule-based chatbot. We can hard-code some if-else conditions. For example, if a person says hi or hello, the algorithm will say, hi, what's your name? Or hello, what's your name? Depending on whether the user said hi or hello. If the user says Jyoti, the chatbot will use the name and say, Jyoti, which vaccine do you want? And based on Jyoti's response, there will be further rule-based steps. Another example is of a tax calculator. We feed information regarding tax calculation, that is salary, investments, interests, and the tax calculator tells us how much we owe to the tax department. Again, a very specific rule-based system where the tax rules are clearly defined. The examples that we just talked about are honestly not very exciting and constitutes what we call as GoFi, good old-fashioned AI. In GoFi, the rules are hard-coded. Like this chatbot is hard-coded, and so is this tax calculator. We feed in some data related to salary, investments, etc. and the system gives us answers based on some predefined rules. From old-fashioned, let's move to new age. Let's talk about machine learning. Now, machine learning is a subset of AI. Most fascinating examples of AI that we hear about are actually part of this subset of AI. One important difference between GoFi and machine learning is that while GoFi is static, machine learning is dynamic, which means machine learning algorithms can learn the rules from the data itself. Moreover, it can evolve the rules further as they encounter more and more data. Let's understand this with an example. Let's say we want to find the relationship between house prices and house area in New Delhi. So we feed in some data to our algorithm. We say, for house number 1, this is the area and this is the price. Similarly, we add information about house number 2. With these 2 points, our model may say, there is a straight line relationship between house area and house price in Delhi. But as we feed more and more data, as we collect data for more and more houses, our algorithm may say, you know what, this relationship is closer to an S-shaped relationship. So we see that our machine learning algorithm is dynamic. Once our ML algorithm is able to find the relationship between house area and house price in Delhi, the algorithm can be used by a buyer or an officer working in the property registration office to make accurate predictions on house prices. Machine learning can also help government bodies in detecting fraudulent transactions, predicting monsoons, forecasting GDP, decreasing traffic, detecting crimes, and much more. With that, let's move to our third term of interest, that is deep learning. Now, deep learning is further a subset of machine learning. It is a set of algorithms which are mostly used in learning from unstructured data sets like images, audio files, videos, and text information like tweets, news articles, blogs, etc. Conventionally speaking, us humans are very good at interpreting unstructured data sets. For example, if we look at a picture of a wanted person and we have another picture to compare, we can easily say if the 2 images are of the same person or not. But what if we have to compare the image of this wanted person across 10,000 images? then it's going to be a very difficult job for us. This is where a deep learning algorithm can help us. But how does a system understand images or videos or text? Well, the researchers started looking at how a human brain processes an image or text or video. They got inspired and created a set of algorithms called neural networks, which today do a very good job at understanding these unstructured data sets. The word deep is there to indicate that there may be many layers of these neural networks in the algorithms. Some use cases of deep learning include face recognition to identify missing people, voice assistants like Alexa and OK Google to increase accessibility, identifying traffic violations, land use mapping, summarizing big reports, and even self-driven cars. Last but not the least, let's also understand what ML cannot do at the moment. At the moment, ML algorithms cannot display artificial general intelligence. Most algorithms are very use-specific. There will be one algorithm to identify frauds, another one to recognize faces, and yet another one to understand sentiments. Whereas we as humans can do all these tasks with just one brain. So we display general intelligence, whereas most algorithms display narrow intelligence till now. So all those movies about robots taking over humans are quite far-fetched at the moment. Machine learning algorithms can also not give us good results with small quantity or bad quality of data. And we also saw this in the Delhi house price example, where with just 2 houses, our ML algorithm was saying that the relationship is a straight line and not an S-shaped curve. So in this video, we learned about artificial intelligence, machine learning, and deep learning. We learned about the relationship between the three. We also talked about some examples of each of them. Finally, we also talked about what machine learning cannot do at the moment. Hope you found the information in this video valuable. Till then, keep watching, keep learning.